Hello children, my name is Krishna and today our topic is about measurements. So coming to the definition of measurements is nothing but measuring the unknown quantity with a known quantity. Measuring the unknown quantity with a known quantity. With a known quantity. So that means whenever we have an object of certain mass, actually we don't know the value of certain mass, but we have already known values of mass like 1 kg, 2 kg, 3 kg and so on. So by comparing this unknown quantity with these known quantities, so by measuring this unknown quantity value with the help of known quantity values is nothing but a measurement. So this mass of an object can be measured by using balances like spring balance, common balance. So these are used to measure the mass of object. One side you can place the known quantities and another side you can place the unknown quantities so that we can get the value of unknown quantity. So by using this we can measure the unknown quantity value. So measurement, it is nothing but measuring the unknown quantity value with the help of standard known quantity values. For example, if you have a fever, so how can you measure the fever? How can you measure the body temperature? So it must have a certain standard known values. So by using the standard known values, that body temperature can be measured by using that standard known values. So these measurements plays a key role in our physics. Not only in physics, to measure any qualities in any subjects, in any various topics, you can use this measurements. So this measurement plays an important role. Here in this measurement, the term quantity is important. Quantity is nothing but the size. Simply we can say that quantity is nothing but a size. Okay, right. So not only size, along with you can say the amount of, we can say that it has a magnitude. Okay, size, magnitude. Now, so this generally can be represented it as a quantity. For example, if you are carrying a mass of 5 kg, if you are carrying a mass of 5 kg quantity, here how much quantity you are carrying? You are carrying 5 kg of quantity. So in this way, the quantity is nothing but the number, numerical value or size, magnitude. In this way, we can represent the quantity. So generally, this quantity generally we call it as a physical quantity. What it is? Physical quantity. A physical quantity is nothing but the quantity which can be measurable. The quantity which can be measurable is nothing but a physical quantity. Which can be measurable is nothing but a physical quantity. So whatever the quantities which you can able to measure, those all the quantities are nothing but a physical quantity. So examples for this physical quantities comes under length, mass, time, temperature, speed, distance, displacement, velocity, acceleration, pressure, impulse, momentum, and so on. All this comes under the physical quantities. We can measure the length. Remember the length, mass, time, temperature, speed. Not only this, there are so many physical quantities are there. So the length, in the case of length, breadth, width, height, distance, displacement, radius. So all these are the physical quantities which comes under the category of length, because breadth, width, height, depth also, right? So all these values are measured in meters in SI system only. In SI system, all these physical quantities are measured in meters only. So that's why the length basic unit is meter. So that depth, breadth, width, height, distance, displacement, and radius comes under the category of length. Wherever these terms are used, that those are nothing but length. Those are nothing but length, because length has a basic SI unit in meters and CS unit as centimeters. So these are the physical quantities. These are the physical quantities. Definition coming to this, the quantity which can be measurable. So we can measure anything. We can measure the height of the chalk piece, the width of the chalk piece, the diameter of a chalk piece, okay, the mass of a chalk piece. So whatever the quantities which we can able to measure, those all quantities comes under the category of physical quantity. Right. Next, unit. Next one is unit. Unit is nothing but the standard value. What it is unit? Unit is a standard value. A standard value which is used to measure the physical quantity, which is used to measure the physical quantity, so that these physical quantities can be measured with the help of unit. So as I already said that it is a standard value. So measurement is nothing but measuring the unknown quantity with a known quantity. Here known quantity is nothing but a standard value. By using this standard value, we can measure the physical quantity. So examples are, for length it is meter. I am saying SI units only. For mass it is kilogram. For time it is second. For temperature it is Kelvin, and for speed it is meter per second. So in this way we can say the examples for unit. Next one it is numerical value. What it is? Numerical value. So a numerical value is nothing but a number. Numerical value is nothing but a number. Numerical value. A numerical value is nothing but a number, so that the number of times it can be defined as the number of times a physical quantity can be represented. A physical quantity can be represented. The number of times a physical quantity can be represented is nothing but a numerical value. So coming to the example for the numerical value, let's say the mass of an object is 5 kg. 5 kg. Here 5 represents the numerical value. Here 5 times the kg represents the mass of a physical quantity. Or 20 meters. Here 20 represents the numerical value. The length of an object is 20 meters. Here the length is repeating 20 times the meter, or 50 seconds. 50 seconds. Time. Here time is repeating 50 times a second. So here the number which gives the numerical value, and it is also called as a magnitude. This is the number, it is also called as a magnitude. So from these three terms, there is a relation between these three. Physical quantity is equal to physical quantity is equal to numerical value into unit. Physical quantity is equal to, simply P is equal to NV into U. So by examples we can easily classify that what is physical quantity, what is numerical value, and what is unit. Let's say length is equal to 13 meters. Length is equal to 13 meters. Here length is the physical quantity, numerical value is 13, and unit is the meter. Can you give any examples? Mass is equal to 5 grams. Say mass comes under physical quantity, 5 is the numerical value, and gram is the unit. So from this equation, if we compare same system of unit same system of unit is the same physical quantity. Here, if we compare the same physical quantity, from this we have a relation to convert from one system to another system. From this we have a relation. For example, if there are two physical quantities, which means not physical quantities, right? Length of an object is 20 meters. So I need the value to be converted in another system. Here 20 meters is the SI system, but I need to convert this into another system, to another unit. Same physical quantity to convert it into another unit. So from this above equation, n means numerical value into u, unit, is equal to n into u. That means here 20 meter, I am saying that 20 is n and meter is unit. So I need this value it is one value and to be converted into another system. So it is the first value which is to be converted. So I mark it as n1 u1. n1 u1. So n1 u1. Okay. So I need to convert this 20 meters to centimeters. Dash centimeters. So here I don't know the n2 value and I know the u2 value. So from this, to convert from this system to another system, we have a relation, that is n1 u1, as we already know that, and to n2 u2. So n2 u2, it is a relation to be converted. So here n1 u1, as we already know that, n2 u2, here u2 we already know, that is in centimeters. In the n2 we have to find out. So out of 4 terms, we know 3 terms. Can we get the another term? Definitely. So from this N1 U1 is equal to N2 U2. I need the N2 value, so that here U2 is in product with N2. So if we send this U2 to left hand side, what happens? It converts it into division to N1 U1. So N1 U1 by U2 is equal to N2. So I got that N2 value. So here N2 is equal to N1 U1. Here N1 is 20, U1 is meter by U2 is centimeter. So I will give the multiples and submultiple tables in the next class, so that we have the some multiple and submultiple values. So to convert the problems, so 20 meter by, here centimeter, the C value is 10 power minus 2, 10 power minus 2 meter. So here centi means 10 power minus 2 and meter is common. So the common things gets cancelled. 20 meter, 10 power minus 2 meter. So meter gets cancelled. So that 20. Here 10 power minus 2 is in denominator. So if it sends to numerator, this 10 power minus 2 becomes 10 power plus 2. So that 10 power 2. 10 power 2. That means that is equal to, here I am writing this 20 as 2 into 10 into 10 power 2 into 10 power 2. So 2 into, when the bases are same, 10 and 10, the power should be added 2, and here to this 10 in the power there is nothing value is there. So if nothing value is there in the power, the value is 1. So 2 plus 1, that is 10 power 3. So 10 power 3 is nothing but 1000. So the value is 2000. So 20 meters is equal to, therefore 20 meters is equal to 2000 centimeters is the answer. In this way, we can convert one system to another system with the help of the relation N1 U1 is equal to N2 U2. So this also can be written as, write all the N terms on one side and all the U terms on another side. N1 by N2 is equal to U2 by U1. U2 by U1. So in this way, we can make the relation between the numerical value and a unit of two different systems. Here the physical quantity is same. The physical quantity is same. The physical quantity here is length. We are measuring the length in one system to another system. That means here meter is the standard value. It is the SI system, and centimeter is CGS system. So in this way we can measure the physical quantities. Okay. Next, so types of physical quantities. Next one is about types of physical quantities. So basically, the physical quantities are classified into two types. Physical quantities are classified into two types: fundamental physical quantity and derived physical quantities. Fundamental physical quantities and derived physical quantities. So fundamentals, by the letter meaning, by the word meaning, fundamental. Fundamental is nothing but a basics. So these are the basics physical quantities. So these physical quantities are important. Depending upon these physical quantities, we have the derived physical quantities. So remember, fundamental is nothing but a basic. So the fundamental physical quantities can be defined as the physical quantities which are not depends on any other physical quantities, So these are the basic physical quantities. These physical quantities which does not depend on any other physical quantities, and these fundamental physical quantities are limited, children. There are 7 fundamental physical quantities. How many? There are 7 fundamental physical quantities. Right? So here I am writing the 7 fundamental physical quantities along with the SI units and CGS unit. So by this we can complete that fundamental physical quantities. So fundamental physical quantities, there are 7. Those are first one, length, mass, time, temperature, electric current, or simply we call it as a current, amount of substance, and finally luminous intensity. So these are the 7 fundamental physical quantities. Okay, so to these 7 fundamental physical quantities, there should be a standard values which are used to measure the fundamental physical quantities. So those standard values are nothing but fundamental units. As I already said that fundamental physical quantity is nothing but the quantity which can be measurable, and unit is there to measure the physical quantity. Okay, the same way the fundamental physical quantities are there which does not depend on any other physical quantities. So to measure these fundamental physical quantities, there should be units, and those units are called as fundamental units, which are going to write right now. So I am writing here SI and CGS also. SI and CGS. Okay. So for length, the SI unit is meter, M symbol. CGS unit is centimeter. For mass it is kilogram, symbol kg, and CS it is gram, symbol G. For time it is second, S, and for CGS also it is second, S only. For temperature it is Kelvin, K, and in CGS degrees Celsius, or in sometimes we can measure it in Fahrenheit also, but basically Celsius is taken as a CGS value. For current it is ampere, A, there is no CGS. For amount of substance it is mole, MOL is the symbol, there is no CGS. For luminous intensity it is candela, simply CD, there is no CGS. So remember, these 7 fundamental physical quantities are very important, and these are the basic fundamental physical quantities. So remember the units in both SI and CGS for each and every physical quantity. It's better to know the SI value and SI unit and CGS unit. Why? Because to make the conversions, to make the problems easy, we must know in both SI system of unit and CGS system of unit. For length it is meter, centimeter, mass, kilogram, gram, time, second, second temperature, Kelvin, degree Celsius, current, ampere, amount of substance, mole, luminous intensity, candle. Right. Coming to the derived physical quantities. Derived physical quantities are the quantities which depends on other physical quantities. The physical quantities which depends on other physical quantities. Other physical quantities. Which depends on other physical quantities are nothing but derived physical quantities. So remember, so these derived physical quantities are unlimited. So many derived physical quantities are there. So these physical quantities depends on other physical quantities or by the derived physical quantities. So here I am giving the examples for derived physical quantities. The examples are, let's say, speed. Okay. So here I am writing the formula SI unit and CS unit also. Okay, ma? Speed formula distance by time. Speed formula is distance by time. In SI unit here, SI unit is for distance. Distance are the average, the distance is nothing but a length. So distance as the SI unit is meter. Meter by time. Time SI unit is second. Meter by second. Coming to the CGS. So CGS distance is nothing but length. Distance unit is centimeter, and for time it is second. Centimeter by second. Why it called as a derived physical quantity? Which means here the speed depends upon distance and also time. So the speed depends upon two physical quantities, two fundamental physical quantities. So it depends upon two fundamental physical quantities. That's why we call it as a derived physical quantity. Next, velocity. It is displacement by time. Displacement by time, and the SI and CS units are same as the speed. SI unit is meter by second, CS unit is centimeter by second. Next, another example is acceleration. So acceleration formula, change in velocity. Change in velocity by time. Acceleration is equal to change in velocity by time. So the unit for the formula for velocity is displacement by time. So unit is meter by second. So meter by second by, for velocity unit is meter per second, and for time it is second, that is meter by second square is the SI unit. For CS unit it is centimeter by second square. So here acceleration depends upon velocity and time, two physical quantities. So that's why this acceleration also comes under derived physical quantities. Okay, now? Right. So again, under this fundamental physical quantity, there are two supplementary physical quantities. And these two supplementary physical quantities comes under the category of fundamental physical quantity. So including these 7 and 2 supplementary physical quantities are there. These 9, 7 plus 2 comes under this fundamental physical quantity. The two supplementary physical quantities are supplementary physical quantity. The two supplementary physical quantities are plane angle and solid angle. Plane angle and solid angle. Plane angle, solid angle. The plane angle unit is radian and the solid angle unit is steradian. So to measure the values in angles, degrees, we will use this plane angle and steradian solid angle. So basically in mathematics we will use plane angle converting degrees to radians. So mostly we will use the plane angle. In rare cases we will use the solid angle. Okay, Nama? So this is what about fundamental physical quantity and derived physical quantity. So under this fundamental physical quantity, it is also subcategory the supplementary physical quantity. So total 7 plus 2, 9 fundamental physical quantities are there. Right. Next, it is about systems of unit. It is about systems of unit. So we have 4 types of systems of unit. System of unit or systems of unit. So we have 4 types of systems of unit. First one is FPS system. FPS system. This FPS system is also known as British system. Second one is CGS system. It is also known as French system. Next one is MKS system. It is also known as our Indian system. Finally, SA system. So total how many? 4. FPS, British system, CGS, French system, MKS, Indian system. And SA stands for System of International or International System. So in these 3 systems, all the first letters F, C and M represents the length. All the center P, G, K mass. And all the last letters S, S, S represents the time. So for length in FPS system, the unit for length is foot. This F. And in CGS system, the unit for length is centimeter. That is cm. In MKS system, the unit for length is meter. M. Okay. Next, in FPS system, the unit for mass is P stands for pound and the symbol is LB. In CGS system, the unit for mass is